In today's reference guide, we'll be looking at our second method of factoring, and this method is called the product sum method, and we'll look at why it's called that in this reference guide. So we've already looked at factoring by way of GCF, and anytime you're given an expression to factor, the first thing you should do is look for a GCF, look for a greatest common factor. If one exists, then you always factor that out first, and then you carry on, and your next thing to try is the product sum method. It may be possible to also factor with the product sum method, or maybe just a GCF can come out, or maybe the expression itself doesn't have a GCF, and you would just go right to product sum method in that case. So at the top of this reference guide, you'll notice that we have a couple of terms. Those terms are binomial and trinomial. A binomial is something that we've discussed in class already. It's an algebraic expression consisting of two terms. So anything with two terms is what's called a binomial. So for example, we could look at something like 3x plus 6. Well, if we look at 3x plus 6, the 3x is term 1, the 6 is term 2. Another example is maybe x squared plus 7. Well, that's also a binomial. It contains just two terms. A trinomial, is an algebraic expression consisting of three terms. So in a trinomial, you would have a term 1, you would have term 2, and then you would have a constant at the end, which is term 3. Okay? And we'll be working a lot with trinomials when factoring with the product sum method, pretty much exclusively with a couple of little exceptions. So it's important to be able to distinguish between those terms, and one operation you'll be required to do with one of those terms is binomial multiplication. We talked about binomial multiplication a little bit in the past, but we'll revisit it right now. Binomial multiplication is when you use the distributive property to multiply two binomials. You make sure that everything in the first binomial is distributed amongst everything in the second binomial. And you can do that by way of arrows. And we see the example down here where this person has taken 5x and multiplied it by 4x to get 20x squared. They've then taken their 5x and multiplied it by 1 to get 5x. Now it's important to remember that you multiply both parts of the first binomial by both parts of the second. So we're done with the 5x. We've multiplied it by both parts of the second binomial. Now we move to the minus 3. Minus 3 multiplied by 4x is the minus 12x. Minus 3 multiplied by positive 1 is minus 3. That's what's meant by binomial multiplication. It's distributing both parts of a binomial by both parts of another binomial through means of multiplication. When you're done, you may notice that the 5x and the negative 12x are like terms. So they get collected or they get added together to give us the negative 7x that you see there. Okay? So binomial multiplication will be something that's really important. It's not something that we're going to be outright doing right now. We will do it a little later on in this unit. But where binomial multiplication will be a really useful tool for you is you can check your answers by way of binomial multiplication. And by checking your answers, you can be confident that the work you're doing is correct, which is always a useful tool to have in your back pocket. So when you're done factoring by way of product sum, which again is what we'll be doing today, you'll use binomial multiplication to check your answer. And we'll take a look at how to do that in a minute when we do some practice problems. When solving these problems, there is a list of steps that you solve that will get you to your final answer. So the first thing you want to do is you want to arrange all terms so the value of their exponents, which is called the degree, is in decreasing order. So typically with these problems, you'll have a value that's an x or y squared, or it'll be some variable squared. Then it will be just a value that may have a coefficient with an x after it, and then you'll have a constant at the end. You always want your x squared value first, then your x value second, then your constant third. So if a problem is given to you that's jumbled up and not in that order, the first thing you should do is put it in that order. Make sure that your exponents, or the degrees, decrease. Step 2, if there's a GCF, factor it out. So that is something that we looked at in reference guide entry number 4. That is your first means of factoring always. Always pull out a GCF if you can. To use product sum, the trinomial must be in this form right here. And again, you'll just notice that the degrees or the values of the exponents decrease. So there can't be a coefficient in front of your x squared variable. It must be 1 to use product sum. Number 3, determine the factors, and this is why it's called product sum, that multiply together to equal the value of the constant. And from those factors, you want to choose the pair that add together to give you the middle coefficient. Only one pair of factors from your list will do that, and we'll list some out in a minute, and we'll show how we make that choice. Then step number 5, your final step, is you write your final answer as a product of two binomials. That will be the solution or the factors to your original trinomial. So let's take a look at a sample problem. So we factor, or if we're asked to factor b squared plus 19b minus 20. We make sure that our degrees are decreasing, or the value of our exponents is decreasing, which it is. At the beginning, we have an exponent of 2. In the middle, we have an exponent with a value of 1. And at the end, we have a constant or no exponent. So with product sum, we want to find the two numbers that multiply to give us our final value, and also add to give us our middle coefficient. So in this question, we're finding the two values that multiply to give negative 20 and add to give plus 19. So our first step then, if we're trying to find two numbers that multiply to give us some other number, that's just another way of saying what are the factors of, in this case, negative 20. So start by listing the factors. 1 and negative 20, 2 and negative 10, and 4 and negative 5. But remember, the negative can also go on the other number. So negative 1 and 20, negative 2 and 10, negative 4 and 5. Now if we look at this list of factors that I just mentioned, that are the factors of negative 20, only one combination, only one pair of factors will also add to give plus 19. And that combination is right there. Negative 1 plus 20 is the same as saying 20 minus 1, which is 19. Do not get mixed up with this one. Plus 1 and negative 20. They add to give negative 19, but it has to give positive 19. So then we write our solution. We just start by listing the variable. In this case, it's b. So we open up two sets of brackets. b goes at the beginning, and then the factors go at the end. b plus 20 and b minus 1. And those are the two factors that will give us b squared plus 19b minus 20. And now if we want to see why binomial multiplication was important, we can check and make sure that these are actually the factors for that expression. And we do that by multiplying these binomials. So we're going to use the distributive property to distribute our b. So we multiply b by b, which is b squared. Then we multiply b by minus 1, which is minus 1b. Then we distribute our 20 amongst both terms in the second binomial. 20 multiplied by b is 20b. 20 multiplied by minus 1 is minus 20. When we combine our like terms here, we get b squared plus 19b minus 20. And we want to make sure that that's where we started, so we can look up at our original expression, and if they match up, then that would mean that you have factored that correctly. And that's where binomial multiplication becomes very important, because binomial multiplication is a check to make sure that we've factored properly. There's another question that's done for you on your reference guide that we'll just quickly go through. In this case, there's no coefficient in the middle. So it's always implied, if nothing is written in front of your variable, that there's a 1 there. So we want the two numbers that multiply to give us negative 12 and add to give us negative 1. Well, in order to find that, we need all the factors of negative 12. So you can see those are listed below. 1 and negative 12, 2 and negative 6, 3 and negative 4, and then we put the negative on the other value. Negative 1 and plus 12, negative 2 and 6, negative 3 and 4. The two which add up to give us negative 1 are those factors. 3 plus negative 4 is negative 1. Again, Don't think it's this one, because negative 3 plus 4 is plus 1. The sign has to line up. It has to be negative 1. So then we just write our variable. We open two brackets with our variable at the beginning, and we write the factors after. So x minus 4 and x plus 3. So with those two examples in mind, let's look at some on our own. So the first question, and again, this is the last time I'll write this out, but we're going to find numbers that multiply to give us that value and add to give us negative 10. So numbers that multiply to plus 16 and add to minus 6, well, let's figure out all the factors of plus 16 first. There's 1 and 16, there's 2 and 8, there's 4 and 4. But those aren't the only numbers that multiply to give us plus 16, because remember, two negatives multiplied together also gives us a positive. So all of these same terms that we listed before, all the same numbers we listed before and pairs of factors listed before, but if both are negative, that will also give us plus 16. So here we have 6 choices, 6 pairs of factors that multiply to give us plus 16. The only two that add to give us negative 10 are those two. So now we write our variable. So we open up brackets. We lead with our variable, and then we just write the factors in. Negative 8, negative 2. And that's it. That is the factored version of the original expression. And if you don't believe me, let's do a check. Let's distribute the first term of our first binomial by both parts of the second binomial. H times h is h squared. H times minus 2 is negative 2h. Then we distribute the second part of our first binomial by both parts of the second. Negative 8 multiplied by h is negative 8h. Negative 8 multiplied by negative 2 is plus 16. Combine our like terms, and we get h squared minus 10h plus 16. Make sure that that is where we started, and if it is, we can be confident that we have factored correctly, and we have. Okay? So the check, the binomial multiplication that we discussed earlier, is a very, very, very useful tool to have at your disposal. You can check and you can be confident that the work you're doing is correct by using binomial multiplication. Now let's look at the second one. Well, that doesn't look like it's going to work. We have a coefficient in front of the first thing that's written. We talked earlier about how we can't have that if we're using product sum. But if you look closely, you'll notice that it's not ordered correctly. So we're going to reorder it, m squared plus 6m minus 40. And now we want the values that multiply to give us negative 40 and add to give us 6. Well, 1 and negative 40, 2 and negative 20, 4 and negative 10, 5 and negative 8, but also negative 1 and 40, negative 2 and 20, negative 4 and 10, negative 5 and 8. So we have 8 pairs of factors. We want the ones that add to give us plus 6. These are the factors that will do that. So we open up a bracket, we go m minus 4, and we go m plus 10. And I'm not going to check that. We've already checked a couple in this reference guide. You are welcome to check it if you'd like. Okay, so carrying on. Hopefully we're starting to see how these questions work by this point. And then we run into something we haven't seen yet. We have a coefficient in front of y squared. Well, that won't work with product sum. We've talked about that already. However, we also need to think back to something else we've talked about, which is see if there's a GCF. And there is. There's a GCF of 6 in all of these numbers. So if we divide every term by 6, we're left with 6y squared minus 5y plus 4. Well, now we have a GCF, but we also have a trinomial left inside the brackets. And maybe we can factor that by product sum. Let's see. So in order to do this, we need all the numbers that multiply to give us plus 4 and add to give us minus 5. So let's start just by listing the numbers that multiply to give us plus 4. Well, 1 and 4 and 2 and 2, but also don't forget your negatives. Negative 1 and negative 4, negative 2 and negative 2. So we choose the ones that add to give us negative 5, which are these two. So look at that. We can factor it by way of product sum. Now what's important is you still write your GCF out in front of your factors of that trinomial. So the 6 doesn't go away. You carry the 6 with you the entire time, and then your factors for the trinomial that remain are y minus 4 and y minus 1. Okay? Again, you're welcome to check that if you'd like. You would use the distributive property for your binomials and then multiply whatever you get by 6. And now our final example, well now this one's not arranged properly. So negative 4f squared minus 16f plus 32. We want to get positive f squared, so we have to divide everything by negative 4. We notice that there is a common factor. There's a number that divides by everything there, and that's negative 4. That's going to leave us with f squared plus 4f minus 8. So we want the numbers that multiply to give us negative 8 and add to give us plus 4. So let's figure out what numbers multiply to give us negative 8. 1 and negative 8, 2 and negative 4, negative 1 and 8, negative 2 and 4. Well, that doesn't really work because there is no pair of numbers there that add to give us plus 4. If we add 1 and negative 8, we get negative 7. If we add 2 and negative 4, we get negative 2. And we get 7 and 2. Nothing gives us the 4 here that we want. And that might happen sometimes. So this question wasn't meant to be solved by product sum. This question is just a GCF question. So we factor out the negative 4, and you can just leave your answer with that trinomial. You factored out a factor, and now you're left with a trinomial, and you can't factor that any further. So sometimes that will happen, but it's important to always make sure that you try to factor out using product sum if you can. So once you pull out the GCF, try to use product sum. Sometimes you'll be able to, sometimes you won't.